All right, in this video, we are going to look at analyzing these compound interest problems in which we're solving for the time. So the time is right here, right? It's the t value in this equation. Because that's in the exponent, it's a variable in the exponent, we are going to need to use logs for these type of problems. When we solve for the interest rate, we won't need it, but when we solve for the time value, we will. All right, so this says Dylan invested $47,000 in an account paying an interest rate of 4% compounded annually. I'm actually going to stop there because that one sentence gives me enough information to start jotting down variables we know. He invested $47,000 into the account. So that's our that's our principal, that's P. So I know what that is. The interest rate is 4% compounded annually. So 4% is our rate, and I need to express that as a decimal. So don't forget that 4% would be written as 0.04. Okay, I got my rate. It's compounded annually, so that tells me my n value is a 1, which is nice because then r divided by n is just r, and then the n times the time would just be n. Time, rather. Okay, so we've got a lot of this covered so far just from the first sentence. Then it says, assuming no deposits or withdrawals are made, how long would it take to the nearest tenth of a year for the value of the account to reach $79,200? Let me underline the question. How long would it take to the nearest tenth of a year? That's telling me I don't know what the time value is. Okay, so I put a question mark there. That's what we're solving for. But we want the future value of the account to be $79,200. That is my A. So I've got my A, my P, my R, my N. I don't know my T, and that's what we're going to solve for. So let's write this all down. My A is 79,200. Okay, that's supposed to equal, so my P was 47,000 times 1 plus my R value is 0.04 divided by my N, which is 1 in this case, raised to the 1 times T. Now our goal is to solve for T. It's in the exponent. That's going to require using logs, and so I have this box down here to help us. But notice that the box only works if our base is isolated, right? There's nothing in front of it. Our base is this. So we got to isolate that. Now it's not isolated because of the 47,000. So I need to divide both sides by 47,000 first. Okay. Now I've mentioned before, there's nothing wrong with leaving this left side as is. If you're, want to save a little bit of typing, you'll notice they have two zeros. So you can divide both sides, the top and the bottom, by 100. It might save you just a little bit of writing. So I'm going to write now 792 divided by 470 is equal to 1 plus 0.04 over 1. Anything over 1 is itself, and adding 0.04 to 1 makes it look like this. By the way, 1 times anything is itself, so I can just write that exponent as a t. All right, now we're in the position we want to be in because I have my base, and I can rewrite this equation in log form. So down below, b to the x equals c implies in the log form, I'm just going to rewrite it or restate it, b to the x equals c. So I'm going to write the word log. I'm going to put some blanks here, here, here. I'm going to reread this equation above in words, and it'll help me know what to put in the blanks. 1.04 to the t is equal to 792 over 470. 1.04 to the t is equal to 792 470. All right, so now that is our answer on the left here, but according to the directions, we want that time value rounded to the nearest tenth of a year. So we're going to have to go into a calculator and evaluate. So let's do that. So over here, I'm going to type the word log. I'm in Desmos. I'm going to hold shift and the underscore to get a base. I'm going to write 1.04. I'm going to make the cursor go up. I'm going to put some parentheses and a fraction bar. And now I've got a fraction, so I can write 792 over 470. Okay. And so I've got 13.3049. I'm going to write all that out because we're going to have to round it correctly. So 13.3049 is equal to t. Let's go round to what they said to round to first before we actually say we're done. Nearest tenth of a year. So this is the tenths place. I will examine the number to the right. That's 4 or less. So I write 13.3. So 13.3 years. That is how long it is going to take this Dylan to make for his account to reach that amount. Let's try another example. And this one will involve all of our compounding continuously problem. Okay, so it says Adrian invested $790 in an account, paying an interest rate of 6.9% compounded continuously. So we note the 790 is my present value or the principal. The 6.9% is my rate, expressed as a decimal, that's 0.069. The compounded continuously is what's telling me I need this E equation as opposed to the one before. Okay, but I've got my principal and I've got my rate. And E, remember, is just a number. It's not a variable, so that's not even something we need to find out. Assuming no deposits or withdrawals are made, how long would it take to the nearest to the nearest year? How long would it take to the nearest year? So that's T. We don't know that. That's what we're going to solve for. For the account to reach 2,550, that is our A. So we'll know our A, we know our P, we know our R, we don't know the T. And that's what we're solving for. So let's write everything down and see what the equation looks like. So our A is 2,550. Our P is 790. E raised to the R, which is 0.069. And then T is the variable, that we don't know that. Okay, so again, variable and the exponent, I'm going to need logarithms. I've got my log equation down here. We'll use that in a minute. But we can't use it yet because we don't have our base isolated. Our base in this problem is the E. That needs to be by itself. It's not by itself because of the 790. So we divide both sides by 790 first. Okay, again, a lot of times you can do a little canceling because these both have 0, so you can divide the top and the bottom by 10. I think I'll do that. 255 over 79 equals E to the 0.069t. So now I've isolated my base, and I can use this conversion in order to get my answer to isolate the exponent. Okay, so I write down log base something is equal to something. And I read this equation. E to the 0.069t is equal to 255 over 79. So then I fill in these spots, repeating the equation. E to the 0.069t is equal to 255 over 79. Okay, so one thing to point out is you can log base e is actually something you can put into a calculator, and it'll, or at least the ones we use, and it'll be fine. I should remind you though that log base e is also known as ln. So I'm actually just going to rewrite this as ln of 255 over 79. Okay, it's the same thing. The very last thing to do to solve for t is to note that we have to divide both sides by that 0.069. 0.069. Okay, and so now we got to go evaluate ln of 255 over 79 divided by 0.0669. Let me just indicate that that's all in the input there. So let's see what that gives us. So I clear this. You can write L and then N, but you could also go over to functions miscellaneous ln. The parentheses just automatically appear. 255 over 79. So that's a fraction in the input. 255 divided by 79. Okay, now that whole answer needs to be divided by 0.069. So if you put a division here, you are going to now type in 0.069 to get the actual answer. Okay, so just study that. Make sure you understand the difference between the with the location of the 0.069. And so we get our answer of 16.9828. I'm going to write all that down. 16.9828 is equal to t. And then we come back and just note that we probably have to round to something. So we're supposed to round this to the nearest year. So the nearest year. So this is 16.98. So I go to the 6 there and I look at the number to the right. That is 5 or greater. So that means I round this to 17. So my answer is 17 years. Okay, so we've done 2 examples, one with this PERT equation, which essentially involves this ln problem, this ln expression. And we did one involving the compounding a particular number of times per year, which involved a regular log. So give these problems a shot, and good luck.